In a previous lecture, we have seen that these are the Lagrangian equations of motion for the central force field. And as I have explained earlier, if you know the equation of motion for any system, you can calculate all the physical quantities related to that system. For example, if you know the Lagrangian equation of motion for the central force field, I can calculate angular momentum, say, by using this Lagrangian equation of motion. So let us see that mr square theta dot is equal to 0, or we have written in the previous lecture d by dt of mr square theta dot is equal to 0. So this d by dt of theta dot is nothing but the theta double dot. I have written it like this. So if I take integration of this d by dt of mr square theta dot is equal to 0, I can say that mr square theta dot is equal to some constant. Now if I write L is equal to R cross P, which is a definition for the angular momentum, I can put this V as mv, where P is equal to mv, mass into velocity. P is a momentum. Or I can also write R cross m cross r omega, where this v is equal to r omega. So this is the relation between the linear velocity and the angular velocity. V is equal to r omega. So I can write it r m r omega, or I can also write this omega as d theta upon dt. So this omega is a angular velocity, whereas this theta is the angular displacement. So this is the relation between the angular velocity and angular displacement. Angular displacement per unit time, we call it as the angular velocity. So this d theta upon dt is nothing but the omega. So m r square omega, which is L, and from these two equations I will call this as a equation 3, and I will put the value of this mr square theta dot is equal to L. So by these two equations I will call this as a 3 and this as a 4. I can write that L is equal to mr square theta dot. So this is the angular momentum